prepare because as I said, the STAR test, I did a STAR test practice one and I was able to get most of the questions. I only just got 2 questions.
Right. No, and see, one thing is for sure that for all of you, whoever is not running away from maths or any subject for that matter, okay, STAR test is always very easy because it is not meant for grading anybody. It is only meant for just a quick reflection of how prepared you are for the next grade. So it is supposed to be easy. So let me start with what I wanted to do. I mean, when I said that only Mithran is due for STAR test, his STAR test is coming up on Tuesday, and he wanted me to explain certain things. One was on inequality, and second one was one of the questions with geometry that you see drawn on the board. Okay. So if you guys have something that you wanted to wanted me to teach you guys in this class, just let me know, or else let me touch upon these 2 topics that Mithran has listed down. One is with respect to inequality word problem, and second is a problem with geometry that he wanted me to solve. Yeah? So let's start with the first question that I have on the board. Okay, so if you look at this one, if you can see what we have here, there is a bigger circle, the outer circle, the big circle. Inside that we have 2 circles. This is with 6 centimeter diameter, and this is with 12 centimeter diameter. Okay, and he was given 4 options. This was one of the questions that Mithran wanted me to solve, saying that there is a big circle, inside that there are 2 circles, one with 6 centimeter diameter, one with 12 centimeter diameter, and he is given 4 values: 56.52 square centimeter, 141.30 square centimeter, 1017.36 square centimeter, and then 254.34 square centimeters. He's saying that just by looking at whatever information you have, which is the nearest answer as an area for the larger circle. So again, I'm repeating myself. There is a big circle inside which you have 2 circles. One is with 6 centimeter diameter, other with 12 centimeter diameter. And there are 4 options given. And the question says find out which one is the nearest area for the larger circle. The way I will go, okay, what is the area of a circle? What is the formula for area of circle?
3.14 times radius squared.
So 3.14 pi, instead of pi you are saying 3.14 into radius square.
Yeah, same.
What is the radius of the bigger circle?
Radius of the bigger circle.
6, I guess? I can't see it.
So the smaller circle is 6 centimeter diameter, bigger circle is 12 centimeter diameter.
The radius would be 9.
9. 12 plus 6, 18. See what's up? Can you see it?
I think it's a bit blurry.
Can you see it now?
Oh, yeah.
I just got it closer to the board. So there is a bigger circle. Inside that you have 2 circles. Smaller circle is 6 centimeter in diameter. The other circle is 12 centimeter in diameter, and both are inside the circle. So what is the radius of the larger circle?
So 12 plus 6 is 18. So 18 divided by 2 is
9.
9.
So this is what will be the area. Pi r square, pi into r square. So 3.14 into radius square, 9 square is 81.
But I was confused with this. With the smaller circles inside, I thought we were supposed to multiply the area of the two smaller circles, then we subtract it from the bigger circle and get our answer.
No. So again, see what happens is when you have a question. Let me read the question one more time, okay?
Okay. Got it.
Yeah. So this is the question that that Mitran had got. Okay? And let me read it. Okay. Oops. Says which measurement is closest to the area of the largest circle in square centimeters? Which measurement is closest to the area of the largest circle in square centimeter? Simple question, right? So you have one big circle given, inside that you have two circles given, and you know the diameter, from which you will be able to find out what is the diameter from here to here for the bigger circle. Yeah? Which is 12 plus 6, 18, radius will be 18 by 2, and then you do the maths. So multiplying this with this will be closer to this.
Okay.
Yeah?
So it was finding out after just the bigger circle, not subtracting the two circles.
You don't have to, right? It's saying that find out the area of the largest circle. And what is the clue that you have? You can look at these two circles to find out the radius.
Oh, I get it now.
Yeah? So, see, what happens, okay? 80% of the times, we think that the problem is bigger, but actually it's not. See, when the two circles were drawn inside this circle, it was actually a clue given to us, from which you can find out the radius. So, yeah?
Yeah.
Praneeth, are you with me? Yeah. So always see, whenever you get a question, always think that the question that you have, it might feel like somebody is trying to bother you by giving you a lot of cryptic information, but in reality, those are the clues given to you. So look at finding the clue in the question. Look at the question as your friend, that okay, my friend is telling me something, let me extract information from my friend to be able to solve it.
So it's kind of tricking you?
Yeah, I mean they try tricking you, right? I mean if you see too many circles here, it might look like, okay, what do I do? Do I have to add these two? What happens to this area and this area? Don't look at, there'll be information that will be useful and there'll be information that will be not so useful. So you have to omit that unuseful part and look at only the things that are useful for you. Yeah?
Okay.
Clear, right?
Yeah.
Okay. Now, I'm not trying to solve this any further. I was just trying to kind of emphasize that this again falls in the same pattern trend, right? Like I always say, trust, read, analyze, and then just do it. So same approach. Now let's look at the second part or second concept that Mitra wanted me to touch upon. That is inequality. Okay. When you say this, x plus y equal to 50,
Yeah.
you have an equal to sign. It says when you add value of x and y together, it makes it 50. Very easy. No confusion, right? But let's try relating that with a real life problem. Let's say I have two kids. Adding their age together is 17 years.
Mm-hmm.
I'm just saying that, okay? Or let's say the age of my two kids together is 26. Yeah?
Mm-hmm.
So if my one kid is 10-year-old, second kid is 16. If my one kid is 11-year-old, second kid is 15. When my one kid is 12-year-old, second kid is 14. This is exact values, equal to sign. We are talking about equality. Now when you say inequality, meaning when it is not equal, I can put the same thing in a different way, saying that both my kids together, age of my kids together is less than equal to 27. Or I think this, okay, let's not make it confusing. I'll say the age of both my kids is less than 27. It could be 26, it could be 25, it could be 24, it could be any condition that matches this criteria holds true. Are you guys with me?
Yeah.
So when I say equal to, that means exact match. If I say x plus y equal to 20, meaning on no given day x plus y value will be more than 20. It cannot be 19, it cannot be 21. But when I want to keep more options open, that is when inequality comes into play. If I say x plus y is less than 50, meaning x plus y can be 49, it can be 48, it can be 47, it can be 46, it can be 0 also. It can be negative also. Yeah? All the situation, all the condition that satisfies that inequality will hold true. Now, let's say if you are looking at this equation, x plus 16 equal to 24. How many solutions you can get here?
X with
Only one. Yeah?
Yeah, only one.
Only one.
But
Only one. Whatever be the answer. I mean, I don't really care about the answer like I always say. If I have an equal to sign, if I have an equation x plus 16 equal to 24 or x plus 20 equal to 38, whatever it is, there is only one possible answer for that. Meaning when you are dealing with an equal to sign, you are dealing with only one possible answer. Okay? Now, in a linear equation, okay? I'm not talking about quadratic equation so far. So if I'm talking about a linear equation with an equal to sign, I'm talking about only one answer. Now, let's look at x plus 9 is greater than 24. How many answers we are talking about here?
1
Huh?
and 1,
Think about
2.
it's an inequality, right?
Yeah. I said x plus 9 is greater than 24.
I guess it's two.
Okay. Praneeth, any guesses?
Infinite because
In-
there's infinite
yeah.
number.
We are talking about infinite solutions. Why? I said x plus 9 is greater than 24. Meaning, if x is 16, this is greater than 24. If x is 18, greater than 24. X is 17, greater than 24. X is 1000. It is still greater than 24. X is 2000. Still greater than 24. Yeah? And I can still go on. So when you are dealing with inequality, you are essentially dealing with multiple answers. And that multiple could be as many multiples you can think of. I mean, not always you'll have infinite solutions, but I'm saying you are essentially talking about multiple solutions. There will be multiple conditions that will satisfy that. Now, inequality doesn't mean only less than or greater than. It means less than equal to, greater than equal to. And you are still talking about multiple scenarios. Now, let's try solving one problem that Mitran wanted to clarify. So, can you open that problem
Okay.
and read that for me?
Here's the one.
Yeah, can you read it for me?
Which situation best represents by this inequality? 120 less than or equal to 12k plus 29.
Okay. So, in the question, he's been given this inequality equation saying 120 is less than equal to 12k plus 29. 120 is less than equal to 12k plus 29. This is the equation.
Yeah.
Now, he is given some expression, some word problem, saying which condition describes this one. So now can you read those options? So did you guys note it down? 120 is less than equal to 12k plus 29. Okay, I'm going to read the options that are given, and trust me, I'm not teaching you guys anything. We're just trying to solve a problem that you can solve.
Okay,
it.
can I read the answer options?
First one.
Okay, A. Felicia has 12 buttons in her collection. She will collect 20 new buttons every year. Felicia collects buttons for K years. For what value of K will Felicia have at least 120 buttons?
Let me read. Just give it to me. Let me read it actually, so that I can break the sentences. Okay. So there are four options given. Okay. So first, the inequality expression that you have to write down is 120 is less than equal to 12k plus 29. Now let's just hear me out on the sentences given, saying which one represents this inequality. Okay. The question is, which situation represents this inequality that you have noted down? Okay. Felicia has 12 buttons in her collection. She has 12 buttons in her collection. She will collect 20 now.
No, new. It's
Sorry, okay. She will collect 20 new buttons every year. So she has 12 buttons in her collection. She will collect 20 new buttons every year. Felicia collects button for...
Well, how about I'll read it?
yeah.
Because I may have accidentally marked it off.
Okay.
Okay, so can I read?
Yeah.
Okay, Felicia has 12 buttons in her collection. She will collect 20 new buttons every year. Felicia collects buttons for K years.
Okay.
For what value of K will Felicia have at least 120
Okay.
buttons?
Okay. So now the first sentence had one thing that I could make out was she has 12 buttons. That is first statement. She collects 20 buttons per year, right? So she has 12. She has 12 buttons and she collects 20 buttons per year. If she collects button for K years, how many buttons she will have at least? That's the first statement. So she collects 20 per year. If she does it for K years, so K into 20. And she has 12 buttons. See, this is nowhere close to this equation. She collects 20 buttons per year. She is doing it for K number of years. So this many per year she will collect. After K years she will have this many, and she already had 12 buttons. This one is nowhere close to this inequality. Okay. So first one we are ruling out. Are you guys with me so far?
Yeah.
Yeah. So the first statement says that she has 12 buttons and she collects 20 per year. After K number of years, how many she will have? This doesn't fit in this equation anywhere, right? Because 12K plus 29. Okay, let's go to the next one.
Felicia has 20 buttons in her collection. She will collect 12.
Is that 20 or 29?
That's 20. Wait. Yeah, that's 29. No, that's 20.
The equation, what does the equation say?
Wait, 120.
Okay, yeah. Fine, yeah.
Oh, wait, sorry, my bad. Felicia has 29 buttons in her collection.
She has 29 buttons in her collection, okay?
She will collect 12 new buttons every year.
Okay.
Felicia collects buttons for X years. For what value of K will Felicia have at least 120 buttons?
Okay. So she collects button for X years or K number of years?
K number of years.
Yeah. So this one looks closer, okay? I'm reading the sentence one more time. It says that she has 29 buttons. Felicia has 29 buttons. She collects 12 buttons per year. For how many years she has to collect buttons so that she has at least 120 buttons? Yeah? So she has this many buttons. She collects 12 buttons per year. And how many years she will collect so that she has at least 120? So it has 120 or more.
Yeah, but I see the inequality sign is a less than or equal to, so I thought it was at most.
No, she says at least. So at least meaning that or more.
Oh, no. Wait, I'm getting it now.
Yeah?
Yeah.
So you have to always think what will be the sign of that inequality. If you have a question says, okay, if for how many years she has to collect buttons so that she has less than 120 buttons. She has less than 120 buttons, meaning it is less than 120. So meaning 120 is greater than this. If she has at least this one, meaning she can have 120 or more, meaning this has to be 120 or more. 120 or more. So this is how you relate. So this was the second option. Srivatsam and Pranit. Okay. So again, this was a word problem. I'm not going to do the third and fourth option here, okay? Because we got the answer, and again, if we go to third and fourth option, we might end up confusing ourselves. But the point that I'm trying to make is, when you read the question, you'll be able to eliminate some of the answers. The first answer said that she has 20 already, and she gets she has. What was the first option? Just read it from me one more time.
Well, let me get that. Yeah. It says Felicia has 12 buttons in her collection.
Okay. So it says she has 12 buttons in her collection. Our equation is 12 into something. Okay, so first doubt that came was in the first sentence. Go to second sentence now.
Felicia has 29 buttons in her collection.
Second sentence of the first line.
She will collect 29 new buttons every week.
Okay. So here we are talking about multiple of 12, wherein the first sentence said that she has 12 buttons and she will collect 29 per year. So that gives us an obvious doubt that okay, we have to eliminate the first option is gone, because it has if she is collecting 29 per year, my equation is 12 per year, 12 into something. So per year thing is coming to 12. So first one you will have to eliminate. Then you go to second one. So basically you have to use the elimination technique to trim down out of 4 which 2 are more likely, and then among those 2 you'll have to again read the question and pick the most relevant one. Okay?
Okay.
We have not learned anything so far, honestly speaking. What we are doing is, we are practicing the same thing that I keep selling to you guys, right? I call it TRAN. Yeah? Trust, read and read and read, and then analyze, and then N stands for Nike, just do it. Yeah. So any question, okay, be it inequality question or be it any other type of question, you have to always make sure that you read the question again and again to make the question easier. If somebody gives you a very tough question, there is only one trick that makes it easy, is by reading it again and again. If you read the same question 3 times, 4 times, trust me, the question becomes half difficult. So never ever be shy when it comes to reading the question, because that's your best trick, best bet for making it easier. Okay? So read the question again and again, and once you read it, whatever you understand, take some note out of it, and then you will be able to relate. That is where your analysis will come into play. After you read the question, understand it, and then you analyze how will you approach that problem to solve it, okay? And that becomes easy. Alright, so Mitran, whatever task Mitran had given, that part we have covered, and we kind of did a recap of how do we go about solving a problem. We also looked at how we can make the question simpler by reading it and then try doing it. Mostly, that is a norm for you guys to get used to, because in the SAT you will see there will be a lot of questions related to word problem. They'll be giving you a situation, more like a story, and you'll have to kind of identify the clues from that story, use those clues for solving the problem. Okay?
Okay.
So that would be the approach. Now, let's see if Praneeth has anything or Srivatsav has anything for me to explain. Anything that you want me to explain before I jump to my own agenda? No? You guys are happy with your STAR test? Enjoying the post-STAR test experience? Huh? Okay.
Because easy.
Yeah, I mean, see that's what. I still remember the first day when Praneeth came with his mom, right? Praneeth was not saying anything, but his mom was saying that STAR test, how do we prepare for it? And my first statement was, there's nothing that we need to worry about. When it comes to STAR test, we should not be worrying about it, because there are more things, there are other things that we should be actually getting worried about and paying our attention for. STAR test, I would not, if I have to choose between STAR test and the math test or the SAT, I would store or conserve my energy for SAT rather than worrying about STAR test, because STAR test will happen every year. SAT happens once or twice in the final year of the school, which gets you ready for the college, right? So that's what I'll save my energy for. Okay. All right. So let me not stress you guys out much. Let's do some simple stuff. Simple stuff as in, let's do some recap of things that we have learned in the previous classes. Or I'm just trying to see if I can teach you guys something around congruence of triangles. Do you guys know what is congruence?
No.
Congruence.
But is that part of algebra 1?
No, I'm sorry?
Same size and angle.
Yeah, congruence. Okay. You see both my hands.
Yeah.
I put it together. Now, if you see it from this side, how many hands do you see?
1.
1.
If you see it from this side, how many hands do you see?
1.
One. If one of my hand was bigger, one was smaller. If I would have put it like this, it would have showed you two hands, right? At least half of, one hand and some portion of the second hand also, right? Thankfully, my hands are of the same size, like all of you. So that's why you are not able to see two hands or a deflected version of the second hand. Yeah, this is called congruence. If you look at this A4 sheet and this A4 sheet, these two are nothing but rectangles. If I overlay one over the other one or the vice versa, you are still seeing only one page. They are called congruent. Meaning, two shapes are considered congruent if they completely overlay each other. You look at these two erasers. They are congruent. Now, if I talk about in layman's term, two shapes are congruent if all their dimensions are same. If you look at these two rectangles, these are congruent because the length for both of them are same, width for both of them are same. That's why you are able to overlay them. Also, both are rectangle, meaning the angles are 90 degree. That's why you are able to do that. If only the sides were same but the angles were not 90 degree, they would have looked like this. They would have not overlaid each other. Yeah?
Yeah.
So that is what is congruence. Now, there are different theorems. Let's look at triangles. Are these two triangles looking congruent? Are these two triangles looking congruent? No. They are not the same size. Their sides are looking different. Angles also might be different. Yeah? They are not congruent. But imagine the two triangles with all the sides same. This is A, B, C. This is D, E, F. If you look at these two triangles, A, B, C, side A and side D are same, side B and side E are same, side C and side F are same. If these are same, then there is a high possibility that these two triangles are congruent. Okay? Sides are matching. Okay? You can overlay them. Each of them can overlay each other. Okay? Both of them can overlay each other, completely cover each other. Okay? Because they are the same size. So this is called So this, when the two triangles have all the sides same, they are congruent. Okay? You can do that at home. Okay? You can draw two triangles with the same length, with sides of same length. Okay? Let's say one triangle with 4, 5, 6. Second triangle also with 4, 5, 6 as side. Draw these two triangles, cut those triangles and see if you can overlay them. Okay? Try doing that. So there are a couple of theorems. They are called SSS, A ASA, SAS, and other one is called RHS. These are 4 theorems for proving the congruence of triangles.
Okay.
Now, S stands for side, A stands for angle. Now, first one when I say SSS, meaning there are 2 triangles which have matching sides. Side, yeah,
I have nothing like that. Nothing.
okay. So I'm saying the first theorem is called SSS, meaning when you have 3 sides and the corresponding sides are matching, those triangles are congruent, meaning they will completely overlay each other. They are exactly the same. Okay. Now, second theorem says ASA. A stands for angle, S stands for side. So, if you are looking at 2 triangles, angle, side, angle, ASA, meaning 2 angles and the side between them. If between these 2 triangles, this triangle and this triangle, these 2 angles are same, this angle is same, and the side between them is the same, that means they are congruent, meaning other sides will also match, other angle will also match. This is the second theorem. Now you might say how to prove this. I can prove this as well. But, I'm sorry?
I know it.
You know it? Okay. Third one is called SAS, meaning side, angle and the side, meaning 2 sides and the angle between them. So between 2 triangles, if there are 2 sides were matching and the angle between them is also matching, that means that these 2 triangles are congruent, meaning the other side will also match, other angles will also match. So there are 4 theorems, okay? SSS, ASA, SAS and RHS. RHS stands for, this theorem of congruence is primarily for right angle triangle. So R stands for right, S stands for hypotenuse, S stands for side. So it says in a right angle, if there are 2 right angle triangles and the hypotenuse are matching and one of the side is matching, then these 2 triangles are congruent, meaning the other side will also be of the same length and the angles will also match.
Okay.
So these are the 4 theorems for congruence of triangles. Now when you say congruence, right, again remember, once you prove that 2 triangles are congruent, meaning you can say that the sides are matching, the sides will match, the angles will match. This is like, let's say it's saying like, if my house has 2 walls of the same length as your house, then your house and my house is matching, meaning other walls will also match. The other pillars will also match. Same way, when you say 2 triangles are congruent, meaning they have all the properties matching, they can overlay each other, and these are the theorems that that we need to know about. We can actually prove them. Okay, so let's try proving one of them in the next class, and then then you'll be able to relate to that. Okay, I don't know if congruence is taught here the same way, but when I was teaching the 10th grade students in India, I thought, no, this could be something interesting for you guys also to learn at a concept level. Okay. So we'll try proving those those congruence. Okay, at least couple of them to be able to relate and to play with some of the geometry concepts. Okay. Any questions?
Yeah.
I guess.
Okay. And Praneeth and Sivatsav,
Yeah.
were you able to follow what I was saying?
Yeah.
Yeah. Okay. No. I mean, I always feel like asking that to you guys because when I'm on the screen, when I don't see your face, I mean, I start doubting about how effective it is, right? So yeah, okay. All right. So this is on the congruence part. Let's prove one of them, okay? Quickly. Let's try proving one of the congruence. Oops. SAS, this theorem, okay? Meaning two sides and the angle between them. What this theorem says is that if there are two triangles which had equal two sides and the angle between them, meaning let's say, if there are two triangles like this, okay, where this side is equal to this side is equal to this side, and this angle are same, then the triangle is congruent. Okay. Now, when you have to prove that two triangles are congruent, what you have to prove is other sides, all the sides will be of same length. All the angles are, so two sides you already know, these two are same. This are same, this and this are same. How about this side? So,
Oh wait, so the congruence depends upon those lines.
yeah, so this side and this side are same, this side and this side are same, and the angle between them are the same. What happens to this line?
That would also be the same, right?
That will also be the same, yeah, because see, if the lines are away, right, if the angle is different, right, if the angle is different, this will be farther and this line will be different, but the angle is same, meaning they cannot go far, right, and these two sides are same, so the distance between these two will be the same, yeah. So it's like this. You have one line and you have one angle, right? So this distance will change. This line, length of this line will change only based on two reasons. If this angle becomes bigger, this line will go this far, and then the length of this side will be different, right? Here, since the angle is the same and the line is also the same, by no means this side and this side will be different. Yeah?
Yeah.
Praneeth,
Yeah.
is that making sense?
Yeah.
Yeah. Okay. So if we have two sides and the angle between them matching, then the two triangles are congruent. This is practically possible, right? If you still want to prove it, you can simply play with it. Okay. Take two A4 sheets, draw two lines. Okay. Take let's say one is 3 centimeter, one is 5 centimeter. Okay. Draw those two lines. Or take two A4 sheets. Okay. Draw first line of 5 centimeter on one A4 sheet, 5 centimeter on the other sheet. Okay. Then draw a 30-degree angle. Okay. Draw a 30-degree angle, and then that length of the line you can keep as, let's say, 4 centimeter. Here also keep 4 centimeter. Draw the same angle. Now you have just drawn the angle. What you have to do is now join the two corners. okay, of the angle in both the places and measure the length. You'll find both are same actually. If the baseline is same, the angle is same, and this length is same, the line joining the two corners will also be the same. Okay, you can draw that. So this is on the SAS. Now, if you look at ASA, ASA meaning angle, side and the angle, meaning the two angles and the side between them. This is 1, 2, 3, 4. Or let me write this as 1, 2 only. And this is 3. Okay. So now let's look at these two triangles. This triangle 1, 2, 1, 2, meaning these two angles are matching, and this side between the two angles are also matching. Now, tell me, will this angle 3 be same as angle 3? Will-
Stop.
If these two angles are matching, will the third angle also match?
Yeah.
It has to, right?
Yeah, because they make up of two.
Yeah.
Ones.
Now let's. So we have this side